found to be defective. The computer is selected at random, found to be defective. Found to be defective. What is the probability? What is the probability? What is the probability that it was supplied by company Y? What is the probability that it was supplied was supplied by the company Y? What is the probability that it was supplied by the company Y? So at least note down the options also. Option A, 0.1. Option B, 0.2. Option C, 0.3. Option D, 0.4. Option A, 0.1. Option B, 0.2. Option C, 0.3. Option D, 0.4. Everyone has taken this? Right. So we have given the data very clearly. And X supplies 60%, Y supplies 30%, Z supplies 10%. Okay. So from this data, what you can write? Probability that X supplies equal to 60 by 100. And from this, probability that Y supplies equals to 30 by 100. 30 by 100. 30 by 100. And the probability that Z supplies equals to 10 by 100. It is very important to identify the data first. Okay. If you don't write the data clearly, then it will be, you cannot write the answer very clearly. That is very important. So 60% means P of X is 60 by 100, P of Y is 30 by 100, is 10 by 100. Probability being defective. This is very important. Suppose totally it is supplying 1000 computers. Among those 1000, 60% is 600. Among those 600 computers which were supplied by company X, 0.01 are defective probabilities. That means 1 out of 100 is 0.01 means 1 by 100. 1 out of 100 is 1 out of 100 is 1 out of 100 is defective. So among 600, if it is 1000, if out of 600, 6 are defective. So here 2 out of 100 are defective. So here among these 30% means 300. Among those 300, 2 out of 100 are defective. That means 6 are defective. Again here Again here, if Z supplies 100 computers, 3 out of 100 are defective. That is the meaning of it. Is it clear? So among those 600, X supplies something. X supplies something. Among those X supplied, probability of being defective is D given X. X supplied something. Among those defective is 0.01. Okay. Among those X supplied computers, 0.01 defective. Clear? And next, among those Y supplied computers, 0.02 are defective. Okay? That means you have to write 0.02 is a P of D given Y. Among those Z supplied computers, out of 100, 3 are defective. So P of D given Z. 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 Okay. P of D given Z. Is it clear? This is the data identification. Whenever any problem is given, you need to write the correct data like this. Okay. Say yes or no. Somebody please write the message, say yes or no. For the given data, P of X we have written, P of Y we have written, P of Z we have written. We have identified P of D given X. Among those X supplied, defective computers are 0.01 probability. Similarly, for among those Y, defective computers supplied are 0.0. Among those Z supplied, the probability being defective are 0.03. Okay, na? So now what you can say? It is found to be defective supplied by Y. What is the probability that it is supplied by Y? This is the question asked. Supplied by Y means you have got a defective computer, that it must be Y. You have got, this is inverse. You have got defective computer, that it must be Y. That it must be Y. So number of exhaustive events. Whenever probability, write the favorable divided by exhaustive. What are the number of exhaustive events? P of X into P of defective from X R or plus P of Y into P of defective from Y R means plus P of Z into P of defective from Z. Defective from Z. These are number of exhaustive events. What is favorable? What is favorable? Why? Why is favorable? That it must be defective means first you need to add the computer to be supplied by Y and probability of being Defective. That was from y, be given y. So P of, first you have got a defective one. We need to find that it must be supplied by y. This is inverse probability. So the exhaustive events are, it may be from x and defective from x, or maybe from y and defective from y, or maybe from z, defective from z. And favorable is, this is about all possible outcomes. Favorable is, it must be supplied by y, and it is defective from y. Come on, please tell me the answer quick. Make it fast. Make it fast, please. Make it fast, please. Everything is written. You have to say the answer. Don't take much more time. It's a simple calculation. It is a simple calculation. It is a simple calculation. Please do it quick. Make it fast. You are saying yes, sir. But what is the answer? I need the answer. You have written the options also. 0.1, 0.2, 0.3, 0.4. Make it quick, fast. See, don't take much time. Doing calculation quickly also is very important. Why? 60%. Okay. 60 by 100 into it is yeah y but y 30 by 100 into 0.02, that is 2 by 100, all divided by 60 by 100 into 1 by 100 plus 30 by 100 into 2 by 100 plus 10 by 100 into 3 by 100. Okay. Very simple. 100 into 100, 100 into 100 is common. That is very simple. It is pretty clear. 30 into 2, 60 by 60 plus 60 plus 30. 150. 0, 0 gets cancelled. 3 2s, 3 5s. 2 by 5. The answer is 0.4. The answer is 0.4. Okay, for this simple calculation, people are doing research. or maybe I think you are utilizing the calculator. Many of the times it is not required. You can do it quickly. Okay, rather than that, if you are using your brain, you can do the calculation quickly. Is it finished? Copy it. Make it quick, fast. Somebody say yes. Is it finished or not? Finished or not? Yes. Write the next question. Next question. In a housing society, half of the families have half of the families have one child per family. One child per family. Half of the families have one child per family. And the remaining half have two children per family. Two children two children per family. Two children per family. A child is selected at random. A child is selected at random. A child is a child is a child is selected at random. Selected at the random. What is the probability? What is the probability that that the child has? What is the probability that the child has a sibling? What is the probability that the child has a sibling? Actually, it was asked as numerically answered question. You have to say the answer in terms of decimals. Only positive decimals. Okay. So let you people are having capital N number of families. Okay. Let total number of families. The total number of families be capital N. Total number of families be capital N. First group of families have single child. First group means that you denote it as F1 and this is F5. And they are having one child. They are having one child per family. Child per family. Okay. And the second group is having, like the second group is F2. That is also n by 2 number of families. N by 2 number of families. N by 2 number of families. So that it is having two children. Two children. Two children per family. Two children per family. So it is very clear. It is very clear. What is the probability of getting, or what is P of F1? What is P of F1? Yes, please. What is P of F1? Equal number of family size. Half of the families are having single child. Half of the families are having two children per family. If half of the families means P of F1 equals to 1 by 2. P of F2 equals to again 1 by 2. 1 by 2. Okay. Okay. What is the probability of selecting a child? You have selected a child. You have not taken F1 first. You have not taken F1 first. You have selected a child randomly. Okay. So if you choose F1 and taking child is, if you choose F1 and taking child from F1 is, taking child from F1 is, taking child from F1 is, ayyo, you are having n by 2 number of children, out of which you have to choose one. Out of which you have to choose one. Okay. Out of n by 2, I have chosen one child. I have chosen one child. Total number are n families. From one family, from half of the families, you have chosen a child. Okay. F1 is having one child. One child per family means that one C1. One chosen out of that one child in that first half group. Okay. And next, probability of choosing a child from F2. From F2. Yes, come on, tell me. Again in F2, you are having n by 2 families. Choose one family. Choose one family. And from one family of n by 2, and from that family or in that family, you are having two children. So one chosen out of two. One chosen out of two. I repeat, F1 is having half of the families. F1 means half of the family. First group. Second group of families are also half. So first F1 is chosen. F1 is given. In F1, there are n by 2 families. From those, choose one family. In that family, we have only one children. That one child chosen out of that one child in that family. And next, take F2, take F2, and in that F2 you are having again n by 2 families. Among those n by 2, choose one family. From that family, yes, in that family we are having children. One chosen out of those two. Okay, this is the data that you have to write. After writing, it is very simple. You have chosen a child that it is having a sibling. Sibling means is it F1 group or F2 group? F1 or F2? Somebody send a message. Somebody send a message, please. Is it F1 F2? F2, because sibling means brother or sister. Okay, so that you have taken a child that it must be from F2. F2. Okay, so this is equal to how simple total number of exhaustive events. Choose F1, probability of selecting F1, and probability of selecting child from F1. Child from F1. R means plus probability of choosing F2 and probability of selecting child from F2. Probability of selecting child from F2. What is the fact? This is about number of exhaustive events. Only two groups of families are. You may choose the first group and child from it. R means plus. You may take the second group and a child from it. And a child from it. Child from it. So what is the favorable? What is the favorable? Favorable. Having sibling. F2. So P of F2 into P of choosing a child from F2. Choosing a child from F2. Everything is there on the board. You please tell me the answer quickly. Make it fast. I don't want to waste the time. P of F2 is 1 by 2. And the child from F1 is 1 by n by 2. N by 2, C1 is n by 2. Divided by 1 by 2 into child from F2. No. F2 means 2C1. 2 by n by 2. Now 1 by 2 into child from C1 is 1 by n by 2 plus 1 by 2 into 1 by 2 into 2 by n by 2. Two by n by 2. Okay, tell me the answer. Quick. Don't waste the time. Don't waste the time. So 1 plus 2, 3 by n. 2 by n by 3 by n. What is the answer? Somebody write it on the, somebody send a message. No need to send, I have written. If you have doubt, you can ask. Make it quick, fast. I've already finished. You are sending the message. Okay, any doubt? Any doubt? Yes, what's the doubt? Okay. If you are having the doubt, you can write it simply as a message, or otherwise we'll do, we have two more different types of problems, and then we have to discuss the remaining things. I'm giving you only different types of problems. I don't want to drag on the thing based on only one type of model. Okay, just one type of model. In yes, right, good. Write down the next problem. You have given 3 points. You have given 3 points. You have given 3 points. You have given 3 points, of which one has heads on both faces. One has heads on both the faces. Second has tails on both the faces. Second has tails on both the faces. And the third has a head on one side. And the third has a head on one face. A head on one face. And a tail on the other. And a tail on the other. And a tail on the other. Choose a coin at random. Choose a coin at random. And toss it. And toss it. And it comes up heads. And it comes up heads. Comes up heads. What is the probability that the other face is tails? What is the probability that the other face is tails? Other face is tails. Quick. Quick. As we have done 2 problems, you can say the answer now. I think within 2 minutes you can finish. Already we have done 2 things, 2 problems we have done. You might have better understood this. Yes. So here there are 3 points given. Sorry, C1. Let the points be C1. C1 is both heads. C2 is both tails. C3 is one head and one tail. One head and one tail. Coin is taken at random means all are having equal chance of occurrence. Coin is taken at random means C1, C2, C3 have equal chance of occurrence. So P of C1 equals to 1 out of 3. 3 points are there. choosing C1 will be 1 by 3. Please write if you want. Coin is chosen at random out of 3 means at random out of 3 means. P of C1 equals to 1 by 3. P of C2 equals to 1 by 3. P of C3 equals to 1 by 3. P of C1 equals to 1 by 3. P of C2 equals to 1 by 3. P of C3 equals to 1 by 3. Okay. So here I have chosen 3 coins. Any one of those 3 coins in these probabilities. Okay. And the taken coin is tossed. Taken coin is tossed. It turns up. It turns up what? Head. If it turns up head, you have what? You may take C1. It may be head. What is getting head from C1? If C1 is chosen, what is the probability of getting head from C1? C1 is having both heads. Okay. What is the probability of getting head? Definitely you will get head because both the faces are heads. Yes or no? What is probability of getting head from C2? What is probability of getting head from C2? You have to say now, quick, make it fast. Yes, make it fast. Huh? You have to say what is probability of getting head from C2? C2 is having both tails. There is no head. What is it? It's impossible even. 0. Probability of getting head from C3. First C3 taken. First C3 taken, then head from C3. Come on. What is probability of getting head from C3? Speak out, make it quick, fast. Yes? Yeah. C3 is having one head and one tail. How you are saying one? We are having one head and one tail in C3. Then getting head will be 1 by 2. Getting head will be 1 by 2. So what is the question asked? What is the question asked? You have tossed a coin. Already you have got head. You have got head. Okay. That the other face must be tail. In order to get the other face must be tail, what it will be. Right up. When we have tossed a coin and getting head, the other face must be tail means that the tossed coin will be C3. Am I right or not? That tossed coin must be C3. Any doubt? Any doubt? You have tossed the coin, you have got head. The other coin, other side is tail only in C3. So that it will be C3. Now speak up. Come on, quick. What are number of exhaustive events? You may take a coin first, C1, and means multiplication, and add from C1. R means plus. Probability of taking second point and probability of taking head from C2. Head from C2 R. R means plus. Probability of getting C3 and probability of getting C3 and probability of getting head from C3. Head from C3. Okay, head from C3. Right, what is favorable? Then it must be C3. C3 is favorable. So P of C3 and P of head from C3. Tell me the answer quick. Please tell me the answer quick. C3. P of C3. 1 by 3 into head from C3. Head from C3 1 by 2 divided by C1 is 1 by 3. 1 by 3 into head from C1 is 1 plus head from C2 is 0. This is 0 plus next C3 is 1 by 3 into 1 by 2. What is the answer? What is the answer? Answer is 1 by 3. Correct? 1 by 6 by 1 by 3 plus 1 by 6. Taking LCM. This is 2 plus 1. Obviously 1 by 3. 1 by 3. I think in the previous problem you have got 2 by 3 that you should write in terms of decimals 0.667. In the previous problem, the answer you have to write in terms of decimals 0.667. Now it is 1 by 3. 1 by 3 is given among the options. They have given the options or not? No options. Okay. So the answer is 1 by 3. Everybody got it? Yeah, here if it is given option 1 by 3, not so 0.332. Everybody got this one or not? Noted or not? Don't take much time to say the. I'm not asking the answer. Asking whether you have taken it or not. Yes. Write down next. Write down next. Write down next. In a multiple choice question, in a multiple choice question, in a multiple choice question, the probability that don't write in a multiple choice for a multiple choice question. Just start the question with for. The probability that probability that a student knows the correct answer. A student knows the correct answer. Student knows the correct answer is 2 by 3. Student knows the correct answer is 2 by 3. 2 by 3. If he doesn't know the answer, if he doesn't know the answer, then he will guesses the answer. Then he will guesses the answer. Guesses the answer. Then the probability that the guessed answer being correct is probability that the guessed answer being correct is, when you are having 4 options, guessed answer being correct will be 1 by 4. Guessed answer being correct will be, the probability that the guessed answer being correct is 1 by 4. Have you written? Write it. Guessed answer being correct is 1 by 4. Given that a student has answered the question correctly, given that a student has answered the question correctly, student has answered the question correctly, then the conditional probability that the student knows the answer is that the student knows the answer is that the student knows the answer is. Student knows the answer is. Please write down the options: 1 by 3, 4 by 5, 2 by 3, 8 by 9. 1 by 3, 4 by 5, 2 by 3, 8 by 9. See, here we have given only half of the data, not completely. We have 2 processes. One is knowing probability that he knows the answer is 2 by 3. K for knowing. Write down. We have 2 processes. One is knowing, second is guessing. One is knowing, second is guessing. One is knowing, second is guessing. Second is guessing. Probability that he knows the answer is 2 by 3. K for knowing. Okay. If he doesn't know what he will do, he will guess it. Okay, he will guess it. So now you tell me, what is the probability that he guesses the answer? Guessing is procedure. Guessing is procedure. 1/4. Guessed answer being correct is 1/4. Not guessing. We have two processes. One is knowing, second is guessing. If he knows, the probability is 2/3. If he doesn't know, he will guess. What is that? Probability of guessing the answer is 1/3. 1/3. 1/3. Okay. If he knows the answer, by knowingly, can anybody say wrong answer? Say yes or no. By knowingly, can anybody say wrong answer? No one will choose the wrong answer by knowingly. If he knows, then saying correct answer is C for correct. If he knows, saying correct answer is, if he knows saying correct answer is, definitely he will say correct answer. One certain event, and when you guess, saying correct answer is, when you guess, saying correct answer is, when you guess, saying correct answer is 1/4. Okay, 1/4 related to that. Actually, you have this and this. Those two are not given. That data you have to create. That data you have to create. So already the student said the correct answer. Then the probability that he knows is, already the student said the correct answer. Already the student said the correct answer. Student said the correct answer. Okay. Yes. Then the probability that knowing is K given C is equal to, what are possible outcomes? Number of exhausted events. We have two processes. One is knowing P of K and multiplication P of saying correct, and he knows R or means plus. R means plus. Next, probability of saying guessed answer and probability that he say the correct answer. P of G into P of C given G. P of G into P of C given G. Say yes or no? What is favorable thing? That he knows the answer. P of K and P of correct answer when he knows. Correct answer when he knows. Correct answer when he knows. This is equal to. Write the answers quickly. Write the values. Tell me the answer. 2/3. Say correct when he knows 1. Guessing 1 by 3. Saying correct when he guesses 1 by 4. Knowing is 2 by 3. And multiplication, saying correct when he knows 1. Tell me the answer. Don't want to wait much more time. Understanding the problem gives you the data, and saying the answer is worth 1 minute. The answer is 8 by 9. I don't want to do the simplifications. If you want the simplifications, just attend the respective school class. I think in Kite, you people are also having school. You may attend. Yes. Yes. What's the thing that you have written? What's the thing you have written? It's okay. The answer is 8 by 9. These are different kinds of problems which were given in the previous GATE examinations. So these are the problems you can expect. Okay. Next. Write down discrete random variate. Probability of. Can somebody speak, please? You have written something. Yes, please. Any doubt? Okay, mic was not allowed, so you are writing something. I think it is not related with this. So related with this question, if you are having any doubt, you please tell me. You please write there is some doubt. Then I will repeat. Otherwise, we will continue the next one. Next definition, we have write discrete random variate. Some doubt, yes. You want to explain again? So we have given a student knows the answer with probability 2 by 3. P of G. P of G 1 by 3. How you are getting P of G 1 by 3? See, while writing the examination, if you don't know what you will write, you will guess. So P of K is knowing. Knowing is 2 by 3. 1 by 3 means 1 minus 1 by 3. 1 minus 2 by 3. See, P of G is nothing but 1 minus 2 by 3. If you don't know, you will guess the answer. That is given in the content. Don't know is nothing but guessing. So P of G is nothing but P of K complement. So 1 minus 2 by 3 is 1 by 3. That's enough. Okay. Is it clear? Now write down discrete. D-I-S-C-R-E-T-E. Discrete random R-A-N-D-O-M random variate. V-A-R-I-A-T-E. Discrete random variate. Discrete random variate. Variate or variable, you can write. A variate capital X. A variate capital X is said to be discrete. Is said to be discrete. Said to be discrete if it takes finite number of values. Finite number of values. Finite number of values. instead of writing x, you please write xi like this. Xi. Finite number of values means those values may be taken from 1 to n or 0 to n or from any value, any negative value to positive one. Okay. So if it takes finite number of values, you take any finite number of values, finite number of values, then it is called as discrete random variable. Say for example, if you want to take the measurements of the temperature in a day of a particular part of the city, so you will be having a temperature for every hour. Okay, temperature in every hour means what? How many hours you will be having in a day? 24. So the temperature readings will be only 24. 24 is finite. Okay, the temperature may be called as discrete random variable. Okay, right. So that's about the discrete. Now, the probability of discrete random variable is denoted by probability of discrete random variable is denoted by discrete random variable is denoted by probability of discrete random variable is denoted by P of xi P of xi P of xi. Okay. And sum of all probabilities, sum of all probabilities, summation I equals to 1 to n P of xi is equal to sum of all probabilities in any experiment always equals to 1. 1. 1. Cumulative distribution function. Cumulative distribution function. Cumulative distribution function of a discrete random variable. Of a discrete random variable xi. Cumulative distribution function of a discrete random variable is denoted by capital F of x discrete random variable means if it takes finite values, only finite for a temperature for every hour, measurement of temperature, measuring temperature in every hour of a day, or there will be only 24 hours. So if you want to measure the temperature for every hour, you will be having 24 readings. Such type of variable or variate is known as discrete. If it takes only finite values, it is known as discrete random variate. And probability of discrete random variate is P of xi. Wait. Probability of discrete random variate is P of xi. It is only notation. Sum of all probabilities in discrete random variate is denoted by summation I equals to 1 to n P of xi equals to 1. In discrete, for symbol summation we use sigma. because we will be having only finite xi values. And cumulative distribution function, cumulative CUMULATIVE, cumulative distribution, DISTRIBUTION, distribution function, FUNCTION, function is denoted by capital F of x. That is denoted as summation I equals to, if it starts with 1 to x P of xi. You have to sum all the probabilities from beginning till x. Till x. This is cumulative distribution function. Cumulative distribution function, where x is any positive integer. Here write down. Here x is any positive integer. Here x is any positive integer. Any positive integer. Okay, write down. Now write down a problem. This is only the thing which we need to know related to discrete random variable. Whenever discrete is given, it takes finite values. Sum of all probabilities equal to 1. Cumulative distribution function, you have to sum all the probabilities from beginning till that value x. X is any positive integer. Okay. Right now, the probability distribution function is given as follows. Given as follows: 0, 1, 2, 3, 4, 5, 6. Probability distribution function. P of x means P of xi, or P of x means the data was given like this: k, 3k, 5k, 7k, 9k, 11k, 13k. 13k. I use the word probability distribution function. Now you please write the question. Find P of 1 less than xi less than or equal to 4. Second, P of for what value of k? For what value of k does P of xi less than or equal to 2 is greater than or equal to 0.3. Is greater than or equal to 0.3. 0.3. 0.3. 0.3. So based on this, you need to have only the understanding what is discrete random variant. And you need to show the difference. You need to know the difference between discrete and continuous random variant. Okay. So P of 1 less than xi less than equal to 4 means you have to write the answer in terms of the decimals. But we have given k. What is k? You need to find it out. Since it is probability distribution function, okay, xi has taken only 1, 2, 3, 4, 5, 6, 7 values. It is discrete random variable. Write down here. Xi has taken only finite values. Xi has taken only finite values. So it is discrete random variate. It is discrete random variate. Now sum of all probabilities must be 1. Now sum of all probabilities must be 1. Sum of all probabilities must be 1. So what we can say? K plus 3k plus 5k plus 7k plus 9k plus 11k plus 13k equal to 1. Tell me what is the value of k, sir? Somebody please tell quickly. Don't take much time. What is the value of k? 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. 20, 33, 7, 40, 45. 45 plus 4. 40. K value is 45. Oh my God. This is 33, 40, 45, 48, 49k. 49k equal to 1 mark. K equal to 1 by 49. Somebody have written 45 or 49. It's not that. K equal to 1 by 49. Now P of 1 less than xi less than equal to 4 means we have not taken 1 into consideration. P of x equals to 2 plus P of xi equals to 3 plus P of xi equals to 4. P of xi equals to 4. So 2 plus 3 plus 4. 2 is 5 by 49. 3 is 7 by 49. 4 is 9 by 49. Tell me the value. 5 plus 7, 12, 9 plus 9. 12 plus 9. 21 by 49. 21 by 49. 20 by 49. Say yes or no? Yes or no? Next, for what value of k? Here we should not use the value of k. You need to find k such that P of xi less than equal to 2 greater than equal to 0.3. So P of xi greater than less than or equal to 2 means P of xi equal to 0. P of xi equals to 1. P of xi equals to 2. greater than or equal to 0.3. For what minimum value? Please write in the question. For what minimum value of k? Please note that addition in that question. For what minimum value of k? As p of xi less than or equal to 2 greater than or equal to 0.3. Greater than or equal to 0.3. Yes, this implies xi equal to 0 means k. Xi equals to 1 means, yes please. 1 means 3k. 2 means 5k. Greater than equal to 0.3. So this is 9k. Yeah, 9k greater than equal to 0.3. That equals to 3 by 10. Okay, k will be greater than or equal to 3 by 9 into 10. 3 times 1 by 30. So what is the minimum value of k? Minimum value of k for p of xi less than or equal to 2 greater than equal to 0.3 is 1 by 30. For p of xi less than or equal to 2 greater than equal to 0.3 is 1 by 30. 1 by 30. Or if it is asked in terms of decimals, you can write. You can write. What is 1 by 30? 0.0333 so on. 0.0333 so on. The funniest thing is, you have asked a very simple question related to this in the GATE examination. Please note that. Very simple. Even by saying it, you can say the answer. The probability distribution function Everybody got this? Have you finished? Somebody write a message, yes or no? Right. The probability distribution function is given as xi minus 1 plus 1. P of xi 0.5, 0.5. Then it's a cumulative distribution functions. Right now, then it's cumulative distribution functions. Cap left of minus 1 comma cap left of plus 1. Cumulative distribution functions. Cap left of minus 1 comma cap left of plus 1. I don't want to explain anything here. Please tell me the answer within 10 seconds. After 10 seconds, I'll explain the next definition. Yes. What is capital F of 1? F of minus 1? Capital F of minus 1 is equal to summation of the probability where you have only minus 1 to minus 1 only. So P of minus 1. That's enough. P of minus 1 is 0.5 and capital F of plus 1 is P of minus 1 plus P of plus 1. What is that? What is that? 1. This was asked in the examination once. Okay. It is your luck. What, sir? 0.7. Who said 0.7? Minus 1 is 0.5 plus another plus 1 is 0.5. 0.5 plus 0.5 is 1. Why you are writing 0.7? I said it is very simple. By seeing it, you can say the answer. Again, writing such kind of answers. Right, next, continuous random variate. Continuous random variate. Continuous random variate. A variate xi. A variate xi is said to be continuous. Is said to be continuous. 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 If it takes infinite values, if it takes infinite values, are countably infinite values. Infinite are countably infinite. Infinite are countably infinite values. Countably infinite values. Countably infinite values. What is the meaning of countably infinite? Let me explain. You know, infinite means so many. Countable infinite means I said taking reading of temperature in a particular part of a city for every hour means 24 readings you will get it. Okay, if you want to take the temperature reading for every 1 second, for every second, how many seconds you will be having in a day? 1 hour, 3600 seconds. So 1 hour, 3600 into 24. How many? 86,400. I check. 84,600 or 86,400? 24 into 3,600. Yes, please. 86,400. When you are comparing 24, with 86,400, you are saying this is countably infinite. Countably infinite. Suppose if you are having 10 crores of rupees property, okay, compare your property with Adani or Ambani's property. Mukesh Ambani property is around 8 lakhs of crores or some 5 lakhs of crores. Okay, 10 crores compared with 5 lakhs of crores means 10 compared with 5 lakhs is 5 lakhs is said to be huge amount. We say it is countable, it is accountable and countable also. But we used to say it is huge when compared with 10. So therefore, countably infinite means when comparatively it seems to be infinite. So if it takes so many values, but which are countable, we can say that it is countably infinite. Okay, normally now the ragging is prohibited in all the colleges, whether it is medical or engineering college. Sometimes some people used to give a small matchbox stick and ask you to count the surrounding length of the college ground with a small matchbox stick. So you can count it, but it takes time. It will be so much. Okay, that is called ragging. That's enough. Am I right, sir? You may be given a bucket of water and ask how many drops are there in it. It is countable, but it is infinite. So that is countably infinite, right? Countable infinite means when you compare that with some any small value, it seems to be so large that we call it as countably infinite. It's okay. So and the same thing, the probability of continuous random variate at any point is given as P of xi. P of xi P of xi, but xi takes infinite values. Xi takes infinite values. By joining all those probabilities, it will be seems to be as a curve, and we denote it as y equal to f of x. Y equal to f of x and called as probability density function. Probability density function. Whenever continuous random variant is there, we call it as probability density function. Probability density function. Probability density function. Okay. Now the sum of all probabilities. Actually, where you are starting, you don't know. It is minus infinity. Where you are ending, you don't know. The curve may be like this, and you are having infinite points from this to this, and let this be the curve y equal to f of x. Y equal to f of x. Okay, and sum of all probabilities is always equals to 1. Here for summation, in continuous random variate for summation in continuous random variate in continuous random variate in continuous random variate for summation we use the symbol integration integration for adding so many values infinite values we use integration for adding finite values we use the symbol sigma. So where you have started, you don't know. If you know that is zero, you can start with zero. But up to infinity, again it is also infinite values. If you are starting at 1 and ending at 2, you may write 1 to 2. Between 1 and 2, you will be having infinite values. 1.00001, 1.0000011, like that. Between 1 and 2 also you are having infinite values. For using the summation of those infinite probabilities, use the symbol sigma, integral minus infinity infinity, f of x dx equals to 1. In case of continuous random variate, we use the word probability density function. So this is equals to 1. Okay, cumulative distribution function. Cumulative distribution function. Cumulative distribution function of a continuous random variate. Cumulative distribution function of a continuous random variate is equal to P of xi less than or equal to x is equal to integral minus infinity to x small f of x dx. Cumulative distribution function integral minus infinity to x f of x dx. Integral minus infinity to x f of x dx. F of x dx. Okay. Starting with somewhere, maybe from 0, it may be from 1, or it may be from 2, based on the given data. Up to that x. X is any given value. Up to that, you have to add all the probabilities. That probability density function will be given. So this is cumulative distribution function. Here we have some few simple properties. Write down first property. First property. This cumulative distribution function is denoted by capital F of x, small x. This is also denoted by capital F of small x, cumulative distribution function. The first property is capital F of infinity equals to, you have started at minus infinity, ended at x. X means infinity. Integral minus infinity to infinity f of x dx. Always equals to 1. Always equals to 1. Next, second property. Second property. You have written p of xi less than or equal to x. Now I am going to express probability density function in terms of cumulative distribution function. Okay. P of a less than or equal to xi less than or equal to b. This is probability density function from a to b. Okay, na? From a to b. This is equals to, you can write integral a to b f of x dx. Integral a to b f of x dx. So this I am going to write it as integral a to minus infinity f of x dx plus integral minus infinity to b f of x dx. Actually, this you cannot utilize like this, but this is only possible for finite values. But I am writing it to get a formula related to this. So you are starting at minus infinity up to a, and this is up to b. So this value we have asked. This value we have asked. So you may flip this. This will be minus integral minus infinity to a f of x dx plus integral minus infinity to b f of x dx. So minus infinity to a, if you flip the reverse the limits, that will get minus. Properties of integration you may observe. In properties of integration you may observe. So this is now minus f of a, and this is f of b. Capital F of b minus capital F of b minus capital F of a. Capital F of b minus capital F of a. Expressing probability density function in terms of cumulative distribution function. In terms of cumulative distribution function. Is it clear? Is it clear? Say yes or no. Somebody please write, is it clear or not? Quickly we do some problems given in the previous examination. Write down a problem. A continuous random variable. A continuous random variable capital X has a probability density function. A continuous random variable capital X has a probability density function. F of x equals to e power minus x. F of x equals to e power minus x. F of x equals to e power minus x for 0 less than x less than infinity. For 0 less than x less than infinity. Then p of x greater than 1 is. Then p of x greater than 1 is. Please note down the options. Note down the options. 0.368. Second one, 0.5. Third one, 0.632. Fourth one, 1.0. 1.0. Tell me the answer. it takes only 1 minute. If you know the integration, it takes only 1 minute. It takes only 1 minute. So given f of x equals to e power minus x, 0 less than x less than infinity, and we have asked p of x greater than 1. Am I right? Say yes or no. So p of x greater than 1 means integral 1 to infinity, starting with 1 up to infinity, small f of x dx. This is equal to integral 1 to infinity e power minus x dx. Integral of e power minus x is e power minus x by minus 1. Limits from 1 to infinity. So if you write the upper limit, e power minus infinity by minus 1, I'm writing the lower limit. Yes. Yes. Minus lower limit value. E power minus 1 by minus 1. E power minus 1 by minus 1. Speak out. Tell me the answer. Quick. Fast. What is e power minus infinity? What is e power minus infinity? What is e power minus infinity? Come, you can write the answer. Nobody knows. Huh? E power minus infinity. E power minus infinity equals to 1 by e power infinity. E has a value lying in between 2 and 3. Say, for example, it is almost 2.71 something else. If you want, you can note it this way. E has a value 2.71 something else. 2.71 something else. It lies in between 2 and 3. So, some value in between 2 and whole power infinity. Finite times you are multiplying. It will be infinity. 1 by infinity it tends to 0. E power minus infinity is 0. E power minus infinity is 0. Minus of minus plus. E power minus 1 is 1 by e. Tell me the value. 1 by e. Quick. 1 by e. Calculator is not allowed, but it is given in your computer. You are writing computer based test. It will be given on your screen. What's the value? Can somebody say please? 0.368. 0.368. Finished? Any doubt? But anyhow, you people are also having integration. While discussing integration, if you are having any doubt related with integration, I'll just definitely clarify the doubts related to integrations while discussing the theorems on integral calculus. That is in ordinary calculus. Now, is it clear or not? Say your response in 5 seconds. Or write it in 5 seconds. Yes or no? Write the next question. Write the next question. Right. Write the next question. Let capital X be a random variable. Capital X be a random variable. Random variable with the probability density function. With the probability density function f of x equals to 0.2 for mod x less than or equal to 1. Zero point 1 for 1 less than or equal to x less than or equal to 4. 0 otherwise. 0 otherwise. The probability P of 0.5 less than x less than 5 is it's given as numerically answered question. Numerically answered question. Please finish it in a minute. I have to finish some more brief-oriented problems. Amma, here mod x less than equal to 1 means minus 1 less than equal to x less than equal to 1. So this means minus 1 less than or equal to x less than equal to 1. Here again 1 to 4 it is 0.1. Otherwise means if it is greater than 4 or less than minus 1 it is 0. So P of 0.5 up to 5 means it is integral 0.5 to 5 small f of x dx. That equals to. So that equals to 0.5 to 1. It takes the value 0.2. Integral 0.5 to 1. It takes a value 0.2. F of x is 0.2 dx plus integral 1 to 4 it takes the value 0.1 dx plus integral 4 to 5 it takes the value 0 dx. It takes the value 0 dx. వాళ్ళకి చదవాలి చెప్పండి ఎంతమంది సరిపడా వర్క్స్ ఇచ్చి ఆ వర్క్స్ చేయమని ఎగ్జామ్స్ పెట్టండి. That's enough. This is the answer. Just takes only a minute. Tell me the answer. What is the answer? 0. Such simple integrations you are taking much more time means 0.2 is what's a constant can be written out. Integral dx is x. Limits from 0.5 to 1 plus 0.1 into integral dx is x. 1 to 4 plus this is 0. So this is nothing but 0.2 into x value is 1 minus 0.5 plus 0.1 into x value is 4 minus 1. Prepare for some examination. Okay, this one. Example. So tell me what's the answer? 0.5 into 0.2. What's that? 0.1. 0.1 into 3. 0.3. The answer is 0.4. The answer is 0.4. Everybody got it? Got it or not? Say yes or no. Send the message in 5 seconds. Yes or no? Yes. Right, next another question. Related to this only. We'll discuss the distributions and the coefficient of variation, mean, median, mode in the next class. Lifetime of an electrical bulb. Lifetime of an electrical bulb is a random variable. Is a random variable with the density function. With the density function f of x equals to kx squared. F of x equals to kx squared. K into x squared. K into x squared, where x is measured in years. Where x is measured in years. X is measured in years. In the minimum and maximum lifetimes. In the minimum and maximum lifetimes. Minimum and maximum lifetimes of the bulb are 1 and 2 years. 1 and 2 years respectively. And the value of K is, and the value of K is, value of K is. Now we have given the probability density function f of x equals to kx squared. X is measured in radian. Sorry, yes. X is measured in years. Okay. Minimum lifetime is 1 year. Maximum lifetime is 2 years. Okay. This is nothing but probability density function. If a bulb glows, it will not blink and comes up. If it blinks and comes up, then it will be discrete. Okay. Even if it blinks, it takes infinite values. Right? So, but it is continuous, random, variate. Am I right? And the minimum is 1, maximum is 2. So, what will be the value? Sum of all probabilities. 1 to 2. F of x dx equals to 1. Use this, you will get the answer for you. Since the given function is a probability density function of a continuous random variable, continuous random variable, continuous random variable, as the minimum is 1 year, maximum is 2 years lifetime. 1 to f of x dx equals to 1. So integral 1 to 2 kx square dx is equal to 1. K into integral x square is x cube by 3. Limits from 1 to 2 equals to 1 implies k into k by 3 to I'm writing the upper limit 8 minus 1 is there 1 is equal to 1 implies k equals to 3 by 7. 3 by 7. What is the value of 3 by 7? 0.7428 and 40 7 threes. 7 threes are not. No. 28 means 2. 2 left. 20. So 20 means 7 twos. Anything else? Any value you can write. 7 twos, 14. 60. 7x 0.428, I think. Am I right? So somebody say yes or no. Zero point 428. That's enough. Okay, this is about the continuous random variance. Now, we have to discuss about this binomial distribution, Poisson distribution, normal distribution, and uniform distribution. Binomial takes discrete random variance, whereas Poisson and normal distribution takes continuous random variance. Uniform takes both discrete and continuous. Yes, we will discuss those definitions and we'll do the problems based on those which were given in the previous examinations. Okay, after mean, median, mode, and standard deviation. Once they are not at all much more required related to this, but they were required in terms of the aptitude part. If we discuss those aptitude part also, in aptitude part, no need to discuss those mean, median, mode values. Okay. Okay, that is a part of aptitude actually, but coefficient of variation is included. Right? We'll discuss those in the next class. Do you have the time to continue? Somebody write. Do you have the time to be continued? Say yes or no. Huh? Yes. Can I continue up to 11? Yes. So I think tomorrow, day after tomorrow, most day after tomorrow, we'll continue this class. Okay. Yes, you can take leave. Good night.